All right, can you hear me okay? Yep. We're all good? All right, fantastic. Let's get going then. Hey, welcome to the session. Thank you for coming. Nice to see you. I recognise quite a lot of you. I know I've met quite a few of you during the workshop earlier this week and I've chatted to many of you in the hallways, and it's been fun. So thank you for taking a bet on coming to hear even more from me. We'll hope this is going to be worthwhile. And for the rest of you, hello, I'm Steve. I am a software developer. I work at Microsoft. I'm on the .NET team. And for most of my career, I've focused on web and UI things, which has been good. But recently, I've started to look more at AI things. And within that, it gives me a bit of a reason to focus on the end-to-end picture. So rather than just focusing specifically on like what's the performance of this model versus that model or whatever, I'm personally very interested in the end-to-end story of how are we going to create actual applications that are genuinely of use for our businesses, for our users, that sort of thing. So I've been chatting to many people throughout this conference, and especially at the workshop on Tuesday, about what sort of reasons do you have for wanting to do AI stuff in your application. And I've heard quite a lot of feedback that is mostly quite consistent with each other. So I've been making a little list, and here are some of the main things that people have been saying, or I would tell you if my slide would react. In fact, here we go. Start again, shall we? Right, there we go. All right, some of the reasons why people say that they want to add AI to their application. Quite a lot of them, mostly quite consistent with each other. So we have things like data extraction, where out there in the real world, there's loads of messy, unstructured data, whether it's news reports or market data. Well, I suppose that's probably structured, but, all kinds of free text things that you get, emails and logs from builds and things like that. And people want to pull structured information out of it to do stuff with. We have classification, which is a very classic scenario for AI, where, for example, customers send you messages and you need to route them to the correct departments automatically. Semantic search is very straightforward. We'll talk about how that works on the inside in this talk. Summarization is obviously beneficial when you've got any sort of large block of information and you want to make it shorter. But that can also, interestingly, be sort of the reverse of data extraction. So sometimes you might have large amounts of structured information and you want to condense it all down to just say like a single sentence in English. So maybe you've got the entire history of all your interactions with a customer and all the products they've bought and such like, and you want to summarize that down as a single sentence so you can put it as a sort of headline next to the customer when your staff are working with them. Translation between languages is very obvious. If someone posts a review in one language, you want to show it in another, and sentiment scoring as other of obvious business value too. So a whole bunch of scenarios, and then we can think about different UI patterns that this gives rise to. And two of the most classic ones are chat-based interfaces, where someone's going to type in some natural language and get answers. And that doesn't necessarily have to be a chatbot scenario. It could be, for example, some kind of querying as well, where somebody can type in, show me all the customers who we haven't interacted with for 2 months, but previously spent more than X dollars or whatever. And being able to translate that into a query that can run against your existing data stores. And then finally, real-time voice assistants. I gave an example of that in the keynote yesterday morning, so I won't cover that here, but you can go back and see the recording of that if you want to. So in this talk, we are going to focus very much on the conversational applications. So this is going to be natural language chat type UIs. And it's not because I'm trying to sell the idea that everyone's app should be a chatbot. It's just that there's so many things we can talk about. We've got to focus on something, and this is the thing we're going to focus on. It'll give us lots of opportunities to cover different topics. And this is going to be a very .NET-centric talk as well. That's the whole point of this talk, is to look at how this is done in .NET specifically. If you're not interested in .NET, the doors are still there, even though they're closed. You can still get out. No one will be offended. It's fine. Okay. So the kind of questions that we might want to start asking ourselves are, what is hard or inconvenient about building this sort of application? And since this is a .NET specific thing, what is .NET going to do about it? Well, I could just give you slides, but probably the best way to understand this is if we just jump in and start trying to build some sort of application. So I'm going to use a project template that we've got at the moment in preview, but will be, well, it's going to be in preview for a little while actually, but it's ready for you to try and use it in preview. If you want to, you can install this project template by going to your console and typing in .NET New install Microsoft.Extensions.AI templates. I'll explain what Microsoft.Extensions.AI is in a minute. But this installs some project templates. So at the moment, it's only one, but we'll add some more in a bit. And when you've done that, you can go to your favorite code editor or to the console or to VS Code, VS whatever, and go into File, New Project, and then you can create an AI chat web app. Okay. Now, I did show an example of this yesterday morning as well. So if you were in the keynote, then the first few minutes of this are going to feel familiar, but we will go a long way beyond that throughout this talk. All right. So we'll create our project. We need to give it some name. I'm great at naming, so I'm going to call it My Chat App. All right. And then it asks us a few questions, like what AI service provider do you want to use? Because something's got to actually run the language model, right? Now, we've got this option GitHub Models by default. That's a really good starting point because it's free. All you need is your GitHub account, and I'm sure almost everyone here has got one of those. And if you don't, that's free as well. And the other good option if you're just wanting to work locally in development is Ollama. That will run language models locally on your own workstation, so you can just be offline if you want to. But it is a bit more advanced, and you do need powerful hardware. It can be a little bit harder to get going. So I would recommend starting with GitHub Models if you want. And then if you're thinking about production options, we've got Azure OpenAI platform. But you can also use other services as well. If you want to use Anthropic or Gemini or whatever, it's not too difficult to convert it over to that. All right, I'm going to go with Azure OpenAI just because I've got that set up. And then we also need a place to store some data that we're going to be working on for some semantic search. We've got this local on-disk option to make stuff really easy to get started with, but it won't scale up, so don't do that in production. Azure AI Search, it is good in production, but it's a whole other thing. I don't want to get into talking about that. So I'm going to pick Quadrant, which is a vector database that we can run in Aspire on Docker. And you can use that in production as well. We'll talk about what Quadrant is and how vector databases work in general in a few minutes. All right, so that creates our application. We've got various bits of information coming up in this README. And you can see that because I chose Quadrant, it's produced a multi-project solution that's going to be orchestrated by Aspire. And we'll look into what that does in a minute. But let's just get stuff running for a start. So I'm building. And when that builds, hopefully we'll see the Aspire dashboard pop up. That's going to orchestrate our multi-project and multi-service application. And the first thing we get is an error message, which is a nice start. First error, configuration missing. I didn't specify a way of connecting to this OpenAI service that I said I was going to use. So you do have to put some sort of API key in. You can get one for your GitHub account if you want to, and that's a good way to get started. There are some instructions in here that will tell you a bit about how to do that and how to set this connection string using .NET user secrets. I don't want to show you what my API keys are, so I'm going to use a weird little trick to avoid having to put them in. That won't work for you if you try and do it, because I've just got hacks in place. So for you, you should actually follow the instructions, but I'm going to bypass that and just do that. And when it starts up again, it will now not give me the error and everything's working. All right, okay? So let's have a look at the logs. What do we get? We get a pretty normal ASP.NET Core application, except when it starts up, notice it says this stuff about processing PDFs and ingestion up to date. What's all that about? Well, you can probably guess, but let's go in here and have a look. So here's our default UI, very classic chat type system. The intent is that you can use this as an implementation of a general chat UI for whatever sort of services and data you want to connect to it. It's got a couple of example documents built in here, these two PDFs. So I should be able to ask some questions like, what does the watch do? And then that should be able to search through the data it's got and produce some answers based on that. And it follows the typical pattern of producing citations as well. So if we want to check that it's really right, we can click on that and it gives us a link into the documents and highlights whatever it was talking about. All right, so that's pretty straightforward in terms of getting started. But let's now start thinking about what could get tricky about this and what .NET can do to help with it. So the kind of thing we're building here is something where your code wants to use AI services in some way. So you pick some kind of provider, and maybe you pick OpenAI. So you want to call OpenAI APIs. How are you going to do that? Well, if you're a .NET developer, you'll install the NuGet package, which contains the OpenAI client, and then you'll make calls to it using OpenAI APIs. Very straightforward, so we're all happy with that, right? But then, what if you also want to use Anthropic? Because you've heard their Claude models are really good, and you want to give that a go. Well, you're going to have to do a similar thing. You'll install one of the Anthropic client packages, and then you'll make calls to that using a different set of APIs. You can probably guess where this is going. The next day you decide you want to use Ollama. So you're going to install a different NuGet package. You're going to use a different set of APIs. And that's now starting to seem a little bit laborious. And in fact, it gets a lot worse because let's think about all the other stuff that's built around this. Like, which of these packages supports telemetry? Which of them does logging? Do they support automatic function calling? What about caching? They might all have different capabilities and they might all work in different ways. So can we do something about that? Well, on the .NET team, one of the things that we often try to do is create general purpose abstractions that can help the ecosystem move a little bit faster. So in the way that we've got a standard iLogger for logging or a standard iService provider for dependency injection, could we have a similar sort of standard representation for these kinds of AI services? Well, that's what we've done. We've defined this interface called iChat client. And we worked with just about all the owners of NuGet packages that implement AI services. And we've talked to them and said, hey, it would be a great idea if you were to implement this interface. And the excellent result of all that has been that people have all agreed. And so we've got this now got this excellent ecosystem growing around the iChat client interface. So your code can simply reference that interface on whichever one of these packages you want. And it gets better still, because when we want to talk about all those cross-cutting concerns like telemetry, function calling, caching, and such like, we can now have a standard implementation of that in the box with all the .NET libraries that works on top of iCaching client. So you'll know that it works well and it works in a consistent way across all of those. And you can use that to define your own custom middleware as well, if you want to. Okay? So, could we do anything else to make it even nicer? Well, one thing is, of course, we could put it all in a box and give you some nice project templates, and that's what I'm showing you right now. Okay, so hopefully that seems all right, but I know that some of you in the audience, if you have been doing AI on .NET for a little bit, are probably thinking, hang on a minute, I thought Microsoft said that we're supposed to use semantic kernel, or was it autogen? I don't know. They're always coming up with different .NET AI systems. Like, which are we actually supposed to use? Is semantic kernel deprecated now? Have they killed that? Well, the answer to that is no. So what's actually happened here is semantic kernel has been split in two. And the bottom half of it, the more low-level bit that's just about talking to external systems, is the thing that we've now recreated as a package called Microsoft.Extensions.AI. So that was previously the bottom half of semantic kernel, and we've rebranded it, we've made it much cleaner, we've done all sorts of refinements on it, and we've worked with the ecosystem to get implementations of that for everything. Okay? And then semantic kernel itself and autogen, they are being rebuilt to work as a layer on top of that. So if you want to use just the low-level stuff that works directly with AI services, then you can go straight to Microsoft.Extensions.AI. And if you want to use the higher-level, more opinionated concepts inside semantic kernel or autogen, then you can do that. And you're still using the same APIs, and your code can work across all of these different things. So I hope that makes sense. Right, now let's get back to thinking a little bit about what we can build with all this stuff now. So we're going to go through a bunch of different scenarios, and we're going to start with some stuff that's a bit basic, and you might even have seen some of this stuff before, but then we'll quickly move on to a little bit more advanced scenarios. So we started by creating a project from that template, and we've already seen a bit of retrieval-augmented generation in the browser. So when I ask this question, what does the watch do? The model is answering, but it doesn't have information about this watch baked into the model weights. In order to find out stuff about this watch, it had to do a search. In other words, it was retrieving content that would augment the generation that it was doing. And if we want to look at the code in there, hopefully you won't find that too worrying. So here we've got this Blazor server UI. You can just take pieces out of this if you want to add some kind of chat UI to other parts of your product. It's got this thing at the top where it's telling you about how to get started. It's got these examples of PDFs, but I'm just going to remove those because I find it distracting. Then at the bottom, we've got this survey template thing, which we'd like you to fill out, but I don't want it in my demo, so we'll get rid of that too. And then we get into the AI stuff. So we've got our system prompt defining how this assistant's supposed to behave. We're telling it that you don't answer questions about anything other than stuff that you use the search tool to find. And what is this search tool? Well, it's a function that we're exposing in our list of tools that we're making available to AI. So these are Microsoft.Extensions.AI APIs, the ability to take a C# function and convert it into something that a language model will know how to call. So we'll see that in a sec. We've got a bunch of logic that takes messages from the user, adds them to a conversation, and then starts calling the backend service, whichever one it is, through that interface, and gets responses from there in real time with a streaming response. It adds them into the UI dynamically while it's arriving, and then finally, when that's finished, it will track the entire response in the conversation history so that we can keep asking more questions and don't lose track of it. Okay? And then down at the bottom, we've got our implementation of search async. You can see it takes in a search phrase. So in general, with these kinds of functions, you can take in whatever parameters you want, return whatever type of thing you want, and the AI will decide whether to call it based on the context. In this case, it kind of has to call it because it's the only facility available to retrieve any information. So if I set a breakpoint on that and then come back into my app UI and ask it another question, what's in that emergency kit? And I won't even spell it right. Let's see what happens. It's chosen to do a search, and it's got a search phrase of emergency kit, which is actually spelled correctly in this case. So thank you for fixing my error. And then it's going to do a search. And this is going to be semantic search on a vector database. And I haven't explained that yet, but we will do later in the talk. But just trust me for now that that's a way of getting back content based on the semantics or the meaning of the content, not based on just the text and how it's spelled. So it's not like full text search, it's like full concept search, and we'll talk about how that works in a minute. And so then it's going to return a result based on that. All right? So I hope that's pretty straightforward, and I hope you can begin to imagine how you can add your own functionality into this as well. You don't just have to do searching. You can retrieve information from anywhere that you can get data from. I gave an example yesterday of retrieving the Australian Football League scores. So just for the sake of doing something different, I'm going to go for the classic example of getting the weather. So I want to ask it what the weather in Melbourne is. Obviously, that information is not baked into the model weights in the AI service itself. So we're going to need to retrieve that somehow. I'll add a method called getTemperature that takes a latitude and longitude, and that's going to use this open web service here to retrieve the temperature, or actually the daily high temperature, doesn't matter really. And so that's fine, but the user probably doesn't know what their own latitude and longitude is. I certainly don't know that most of the time. So we'll also add a function called getLatitude-Longitude that takes a location string and calls yet another web service to convert that into a latitude longitude. So we're setting a bit of a challenge for the AI. It has to do a bit of problem solving and work out that if I say what's the weather in Melbourne, it's first going to have to look up the latitude and longitude for Melbourne and then pass those into getTemperature. So let's see if it does. But I also need to include this in the list of tools that we make available. So I need AI function factory. Yeah, that's right. Thank you, Copilot. Okay, so let's get that going again. And it says the type could not be found. Are you for real? What are you talking about? Did I overwrite something incorrectly from here? Yes, I did. So let's just put that type back and try again. Right, so we'll see if it's able to chain those two function calls together and figure out what the temperature is here right now. What's the weather in Melbourne? And we'll see, hopefully, it will hit our breakpoints. Oh, I didn't put a breakpoint in. It would have hit my breakpoints. Well, it's correctly come back with 17.4, is that right? I get 18 right now, but it's close enough, all right? So it must have called get latitude, longitude to find out these numbers, and then it called into get temperature to give as an actual answer, all right? So let's think about extending this now. Let's think about other forms of custom data that we can allow it to search over. And we'll do it the very simplest thing first. It's a bit artificial, you probably won't really do this, but just to prove that it can be done, right? So we've got these two sample PDFs in this data directory here. The most obvious thing we could do is just change them for other PDFs. So over here, I've got a couple of other examples. I've got this scientific paper about using AI systems for medical diagnosis. And then down here, I've got another scientific paper on using AI to generate dance moves. So, you know, both equally valid contributions to science there. And I am going to put these two inside this data directory. And just to show I can remove stuff as well, I'll get rid of that emergency survival kit. So let's run that now. And hopefully it will notice that I've changed that data and it will update the ingestion in the vector database. So if we look at the logs, you can see it's removing the emergency survival kit and it's adding these two other PDFs. And we'll see how that works and customize it momentarily. But now we can ask a question like, mathematically, what's the optimal dance move? Okay, and we'll get out an answer to this question that humanity has been asking for thousands of years. We can find out the optimal dance move is one that optimizes the beat alignment score, BAS, and it can improve your dancing by 12%. All right, let's see if that's true. We'll follow the citation and it takes us into the paper and we can see that that's all valid science. Great. All right, so no, I'm serious, totally. So we've looked at just dropping some PDFs in. That's easy, right? But we don't really want to just do that. We want to pull in data from truly custom sources and customize what it is that gets ingested and how that works. So let's set another challenge, like how do I use iChat client, okay? Now, hopefully, it doesn't know anything about that. It's going to search the data. It's going to make a couple of different efforts to find some stuff. And it says, nah, sorry, I've no idea about that. It probably seems to be something to do with AI. And here's a link to a PDF about AI, but I don't really know the answer. Okay. So I want to give it actual information about how to use iChat client. Where can I get that information? Well, one possibility is we could go onto GitHub and we could find this .NET AI workshop, which has just been contributed free to the world by this random genius guy. And we can go and look in here and we'll see that there's all these markdown files that explain all the process involved in becoming an expert with doing AI programming on .NET. And I want to ingest all this content, but I don't want to download those files. I want to get them directly from GitHub. So I'm going to need to use a library that knows how to connect to GitHub and fetch content from there. So I'm going to go manage NuGet packages, and there's a NuGet package called OctoKit that you might have heard of. That's a .NET library for using the GitHub APIs, and I'm going to be able to use that to fetch some stuff from there. All right, now, how does data ingestion work? Well, I'm going to do it by adding another class here called GitHub Markdown Source, because I'm going to fetch Markdown files from GitHub. And you don't have to do it this way, but one way that you can do it is to implement this interface, ingestion source. That's not like an official thing in Microsoft.Extensions.AI. It's just an interface defined in this project template with an example structure of how to organize an incremental ingestion system. And probably the best way to see and experience and get familiar with that is if I just dump in an implementation and then we'll step through it in the debugger. So let's just fix all these namespaces like this. Are we ready to run? Yeah, good. Right, so I'm going to put some breakpoints in here, and we'll see how this actually works at runtime. And I need to actually trigger its execution as well. Now, you could have a button in your application which is like, redo the ingestion or whatever. And that's up to you to decide how you want that to work in your application. In the sample or the project template starting point, we just do ingestion when the application starts up. Now, I think you probably want to customize that in some way, but it's a good starting point. And so this is what causes it to fetch those PDFs from that data directory. But now I want to also add a further call that is going to ingest data using my GitHub Markdown source, which implements that ingestion source interface. All right, so let's see if this actually does it. I'm going to start up in the debugger, and we'll hopefully watch it go through the process of ingesting some content. So when that starts up, we hit the first thing it does is it says, please tell me what documents have been deleted since the last time you ran. And it provides a list of stuff that you ingested previously, which in this case will be empty because it's the first time that this source has run. I'm not even going to implement that anyway. I'm just going to say nothing ever gets deleted. We'll just return an empty set from that. And then it says, OK, what is new or modified since last time? And this time we'll do a call using the GitHub client to find out what the content is. And you see we've got these 11 markdown files there. And then we'll loop through each of those. And for each one of them, we'll think, OK, is it new or do we already know about it? Now, of course, in every case, it's new because we haven't ingested anything yet. So we're going to add all of them to the list of things that are new. And then after we've built up our list of things that are new and modified, it will call create records for document. And this is the bit where we actually convert it into something that can be put in a vector database. So we download the actual raw markdown stuff from GitHub, and then we're going to split it into little chunks, because when you track stuff in a vector database, you want to do it in little pieces so that each little piece has got its own separate subject matter, and that will make it possible to find it with semantic search. You don't want to put an entire document, like thousands of words in, because it won't all be on the same subject. Right, then we're going to split, then we're going to create embeddings for that and return records that can be stored in a vector database. And if you don't know what any of that means, don't worry, I've got some slides for you in a moment. All right, so we can go and have a look at our logs. You see it's ingesting all that content, and hopefully it finishes doing that. And now, if we say, how do I use iChat client? It will have a whole load of extra expert knowledge from that GitHub repo, and it can produce some genuinely correct and useful code samples for us. So obviously you can use that to pull in your own custom data. But what on earth is all this stuff about embeddings and vector databases? How do they all work? How many of you have used a vector database? Oh, that's actually more than I would have thought. Well, I don't know. Maybe it's like a quarter of the room. All right, so for the other 3/4 of you, what on earth is all that stuff? What even is an embedding in the first place? Well, an embedding is a way of representing the meaning of some content. And I actually do mean the meaning, like not the characters or the words or anything like that, but like semantically what it means to us. So, for example, things like cats and kittens and tigers and pumas and such are all semantically similar, and that would be very, very unrelated semantically to, say, iChat client. Okay? And computing embeddings of stuff helps us to put that into numbers mathematically. So let's say we start from some content, which could be a string, an image, or whatever else. But if it's a string, we will pass it into an embedding model. That's not the same as a large language model or a small language model or anything else. It's an embedding model, and it doesn't generate words. It returns a set of numbers that represents the meaning of the content. Okay, and the whole training process has taught it how to differentiate different kinds of content, different concepts. Okay, so that's just an array of numbers which you will then store somewhere in memory or in a vector database, which we'll get to in a second. And you can use that then to compare the similarity of any two things. Like you've got string A and string B, you get the embeddings for both of them, and then you want to compare them. Because we know that if two things are similar, then they'll have similar embedding vectors, and if they're different, they'll have different vectors. So how do you compute the similarity of two vectors? What does that even mean? Well, it turns out there's a very straightforward algorithm to do that. This is the most commonly used similarity score. It's called cosine similarity. Mathematically, it's equivalent to the cosine of the angle between two vectors, but you don't really have to know about that. All you really need to know as a programmer is that it gives you back a number between -1 and +1, where the bigger the number, the more similar two things are. Okay, and this is what we were doing in our code when we calculated the embeddings of the content that we were working with, and then we sent those embeddings into a vector database. What's a vector database? Well, I assume that you know about things like relational databases or document databases, just a place to store structured information. In a vector database, you have a set of collections. Collections are a bit like tables in a relational database. So you might have one for product chunks, chat logs, one for policy documents, and these are like separate little universes of storage that don't overlap each other. So you just make a different collection for each type of thing that you want to store. And for each item there, you'll keep track of the embedding vector that represents the meaning of it. And you can store any other metadata that you want there. So it's normal to store like the text of whatever it was that you embedded and maybe information about where it came from. And then you can use that for querying for semantic search. So in your code, let's say you want to find stuff that's related to battery life. Well, you will compute the embedding of that string, and then you will send that embedding vector to the vector database saying, give me the closest 10 things to this vector, and it will use cosine similarity or whatever else you've configured to return the n closest matches ranked in order. And hopefully it's got some clever indexing techniques so that it can do that really quickly. So that's what's going on here. We compute the embeddings of our stuff and we return them as one of these records that can be stored in a vector store. And then we've got this semantic search service that we've stored into the dependency injection. And that's what's being called from our search method. And so that computes the embedding of whatever query the AI is trying to do. And then it does the vector search in the vector database and gets the results. All right? So that's some of the basics with this kind of application. Now let's think a little bit more about how it's constructed. Now I mentioned that this uses Aspire orchestration. Aspire is a technology that started in .NET for organizing applications with multiple processors, multiple projects, containers, databases, things like that. It's now usable with other technologies too, and it's configured through code. So we've got this app host that in this case is defining our connection to OpenAI, our vector database, which is Quadrant in this case. Got some feedback. We've got this SQLite database to keep track of what's been ingested. That's actually going to go away in the next couple of weeks because we've got a better way of just storing that in the vector database. And then finally, we've got our actual web UI. All right, that's cool. Another thing that's nice about working with something like Aspire is, we're going to have to run it. It gives you this dashboard that allows us to really see what's going on in our application with telemetry and other things. And for example, we can go in and have a look at a bit more information about our vector database, our Quadrant vector database. And a nice thing about Quadrant is it's got a dashboard that comes built in. So I'm going to go to the dashboard on this magic URL, and it's going to ask me for an API key because Aspire is all secure by default and that, so it sets up an API key, and I can find out what API key it's using by doing this. It's not really a secret because it creates a new one every time we start, and I'm just going to paste that in there. All right, so now we can see the collections in our Quadrant database here. We can see that it's got this one collection that we've ingested 340 points into, and I can go in there and I can start exploring all of these points if I want to, see all the metadata and stuff, but it's not very interesting. Slightly better for the purposes of demos is that I can go into this visualize over here and get it to plot a nice little point cloud of all these points that's ingested. All right, and you can see that they're grouped into little clusters. If I move the cursor, we can have a look at the metadata, and you can see that we've got a file name for each one. So to make this look even better, we can put color by file name. All right, and now we'll be able to see how those different data sources have been mapped into semantic space. Now, apologies to anyone who can't differentiate colors easily, but I'll explain as we go. We've got a cluster up here of green points, and if we look at the text, I can see all of those are stuff to do with dance moves. We've got a cluster of orange around here, which is stuff to do with clinical diagnosis. We've got a cluster down here, which is to do with a GPS watch. We've got loads of stuff overlapping over here, which is different different markdown files to do with working with iChat client and AI programming. And even though these overlap, there are little clusters within it. So there's a little blue cluster down here to do with vision and image processing. We've got a little yellow cluster to do with real-time and voice and so on. So you can see this nice sort of like hierarchy of clusters within clusters and so on, and how your data has been understood by the embedding model that you're using. All right, so that's a nice little thing. Another thing that Aspire aspires to do for you is to make it easy to observe what your application is doing. It's very big on telemetry and observability. So we should be able to see some of that. Let's just reorganize stuff a bit. I'm going to make my application do something like, what's that watch again? All right, let's see if it does a search. Yeah, it does. Cool. But can we find out what has actually been going on behind the scenes? Well, we can go over onto metrics if we want to, and we can see that we've now automatically got these nice graphs, it's a bit hard to see on this screen, of the AI service usage that's happened, counts of the tokens over time, and we can go into one of these if we want to and get information about the entire process that's been happening. So we've got this nice detailed trace here of an operation that, what did it do? Okay, so it started by calling GPT-4o Mini here, which replied to tell us that we need to do a search, and we used our vector database at some point, but that's so fast we can't see it. And then after that completed, we did another call to the language model to generate a final answer. So you can use all this stuff to collect telemetry in production, and that'll give you a good sense of where your costs are and any performance issues that you've got. Like if a certain operation just takes weirdly long, what part of the process was it that took a long time? So that's all great in production. But in development, I don't think it's that great, actually. Now, I personally think that this big sort of chart, like this sort of Gantt chart view of what's happening, is not very easy to understand. It doesn't tell me much about why it did a search or what the search results were or anything like that. So you might wonder if there could be a better view of all this information in development to give you the ability to diagnose and debug a little better. Well, there might be. So I'll give you an example of that later on in this talk. All right, so let's move forward to talk about another area that's got a lot of attention recently, MCP, Model Context Protocol. Who's heard of it? Almost all of you. Who's implemented or consumed an MCP server so far? Yeah, like 6 people. All right, cool. So this thing has only been on the scene for like 1 month or whatever, although that's actually quite a long time in AI terms. It's already been like deprecated twice and brought back, and you know. Anyway, MCP is where a lot of momentum in the AI space is at the moment, and it's a general way of plugging in different facilities to something that has got a chat or an AI interface. All right, I will show you how we can create our own MCP server, how we can consume an MCP server from someone else. But first, let's just think about where this came from and why it works in the way that it does. What problem is this trying to solve? Well, the way this started was with the desire to create plugins for client applications. Okay? There are many different code editors, for example, that have got a chat interface. VS Code is one of them, and there's all sorts of different services built into your operating system or GitHub or whatever else that have got chat interfaces, and you might want to extend them. For example, you might want to be able to connect them to some documentation or to connect them to your live build service, your build server and the status of your builds. Well, the VS Code team probably does not feel very interested in creating a special facility in VS Code for talking to your build server. They want that to be your problem, obviously, and so there needs to be a general way to do this. And the people at Anthropic came up with a general technique for doing it. The approach they came up with is, what if there were child processors that knew how to communicate with each different data source that you want to use? Okay, in that case, the only thing you have to configure in VS Code, for example, is what is the command line command to launch it. That's all it has to know. And then when it's launched that, it can talk to it over the standard input-output channels, and there can be a standard protocol for saying, hey, what resources have you got? What tools do you offer? What files do you know about? And then all of that stuff can be fed into the context of the AI. Right, now more recently, people have said, oh, that seems really cool, but I'm not building a client app, I'm building some sort of web app. I still want to connect to arbitrary external resources without knowing too much about them. Can I use MCP for that as well? And the answer now is yes. And in fact, it's even simpler when it comes to web applications because it's just the typical kind of HTTP requests that you all know and love as web programmers. So let's give this a go. Let's say we want to connect to an MCP server. Well, what should we use? We'll go to the Model Context Protocol repo here, and we can see there's a bunch of reference servers for things like file systems, Git, and Redis, and stuff like that. There's also, excuse me, literally hundreds or thousands of third-party MCP servers that connect to any conceivable thing that you can use, okay? So what should we actually pick? Well, for the sake of making it easy to understand, I'm going to use the GitHub MCP server, because we all know about GitHub, and I want to be able to fetch information about stuff that's in GitHub repos or about Git users. Now, of course, I can't do that right now. It doesn't know anything about them, but I can add that to my application. So firstly, since I want to use GitHub, what does that really do? Well, this MCP server has got features like creating files, search repositories, list commits, and all the stuff you'd expect. And it also tells me what the command line arguments are for starting it up. So I just need to translate this now into a little bit of .NET code. So in my web application, I am going to add another NuGet package called Model Context Protocol. This is the official C# client for MCP. It's just been available for about 2 weeks now. And then I'm going to go to add a new service. So let's create a class called GitHub MCP service. Right. Now, once again, you don't want to watch me type this all out, so we'll just drop our implementation in. It's not very difficult, all right? So we use MCP Client Factory to create an instance of this child process using this command line command, and it's going to communicate over standard input-output. And then we can expose the list of tools that this thing offers to us. In this case, I'm filtering it just to these 2 tools because I want to keep stuff nice and focused and easy for us to understand. All right, so now let's make this available. I'm going to do it in a classic .NET kind of way. So I'm going to go builder.services.add singleton of one of those. All right, so we're doing it through dependency injection. We don't have to, but you know, we're .NET people, we like that sort of thing. Then up here at the top, I'm going to inject one of those. And now I'll need the namespace. Now I also need to get the tools from it. So down here, when we're getting our tools, I'm first going to turn this to be asynchronous because we're communicating across processes now. And I want to get the list of tools, so I'm going to say get tools async, like that, okay? And I've got to await that as well, okay? So let's see if this actually works now. So I am going to see if I can look up the information of someone on GitHub. So wait for that to come up. All right. Can anyone volunteer their GitHub username if they don't mind me showing them on the screen? iCooper? Oh, yes, Ian Cooper. All right. Who is GitHub user? Let's see if it knows about you specifically. Let's see if it can find you, though. There might be other Ian Coopers. So that is hopefully now communicating with the GitHub APIs, and we get a picture of this lovely gentleman on the front row right there. Okay. So thank you to GitHub MCP server. Right, what about creating our own one though? What if we don't just want to use ones that other people have prepared for us? Well, let's say I want to be able to ask questions like, are my builds passing or not? So I'm actually going to connect to the build server that the ASP.NET Core team uses, and we'll check the status of the live builds coming out for the ASP.NET Core repo. Okay, so how am I going to do that? Well, firstly, I'm going to create a separate project entirely, because I'm going to imagine that this has got nothing to do with the rest of my application. This is just a separate thing that we're creating, and we'll be able to reuse it across applications. So I'll create a new project, and I'm going to call it build status MCP server. Okay. And I'm going to not enlist it in Aspire orchestration. I could enlist it, it would be fine, but I just want to really pretend that this is an unrelated project. It's got nothing to do with the rest of my application. All right, so in there, I'm going to drop my ready prepared implementation, and I'm also going to need some NuGet packages. So let's add package references. This up here is the server package for Model Context Protocol that sits on top of ASP.NET Core. Because I'm going to connect to the Azure DevOps instance that produces ASP.NET Core builds, I need this package. Now, if you're wondering why the branding is Team Foundation Server, so am I. But that is the name of the package used. Okay, and then we're going to write a little bit of code. We've actually done it, haven't we? Right, so what we do, we say add MCP server, I'm going to enable HTTP transport, and we can expose some tools. And just to get started, I'm going to create a tool called secret number, and we're going to expose this secret number, and we'll see if our chatbot is able to retrieve that. So let's just check that this all builds, probably does. And because I'm pretending that this is unrelated to the rest of my application, I'm going to go into there and .NET run it on the command line independently of the rest of our application. All right, now we want to consume this, so I need to do the same thing that I did for GitHub MCP service. So I'll add a new item, build status MCP service, like that, and then I'll drop in my implementation, which is even simpler than before. This time I'm using the HTTP server sent events transport. That's like a real-time version of HTTP, and I'm going to need to put in the correct port number, which is 5277. There we go. And then we'll expose the list of tools as a function here. And once again, I then need to go and make this available here, but I'm just going to skip the DI this time. So I'm going to do new build status MCP service, get tools async, like that, and run again. All right, so let's see if we can now get that secret number from our custom MCP server. When this comes back, right, what's the secret number? See what it says. Does it make a call to our MCP service? Oh, I'm unable to disclose the secret number. Why is that? Well, I think that's just because we've referred to it as a secret. So I'm just going to go and change my prompt to you can answer about the secret number. Okay. Now let's see if it's a little bit more compliant this time. What's the secret number? Does it call our MCP server? Does it find out? Yes, it does. Hooray. So we've got our secret number, 1234. Yes. Isn't that a great accomplishment? Thank you. All right, but remember, we actually want to get our build status. Okay? And we can change the tools available from our MCP server without having to coordinate with the applications that consume it. That's sort of the benefit of this independence here. So I'm adding another tool here. Well, let's get this into the right place. Like that and like that. Right, so we've got another tool now called build info provider gets build results, get build results, and it uses this Azure DevOps client stuff to get information from the ASP.NET Core build server. And I'm going to need to put that down here as well, and then I'm going to restart my build. Oh, I've shut down the wrong thing. I was going to show you that I don't even have to shut down my application to get the updated tools, but I have shut it down now. You'll just have to trust me it would have worked anyway, or that I'm very good at lying about making mistakes. So let's see if it works. All right, has the latest ASP.NET Core build passed? Include a link to it. So let's see if the ASP.NET Core team is doing a good job at the moment. Oh no, it's failed. All right, and we've got a link to the latest build, and I can follow that. Is it actually true that it did? Yeah, it did fail. Oh dear, gonna have to get someone to look at that. All right, so that's good news. Right, so we were able to make that work. But one of the other things that we can do when we've got a custom MCP server like this is we can connect it to other tools. That's sort of the point, right? So let's have a go at doing that. I'm going to copy this URL to my clipboard right now. And I can plug this into any other tool that supports MCP. For example, IDEs like Visual Studio or VS Code, right? So we've got this chat window over here on the side, and I can click on these tools here, add MCP server, HTTP, paste in my URL, give it a name, choose where to store it. And once I've done all that stuff, we'll see that it discovers that we've got these two tools available, get secret number and get recent build results, okay? And let's ask it, what's the secret number? And that's going to consider its options of how to evaluate that. And it's actually going to prompt us to confirm that we are willing to call this tool on the MCP server, because it really wants confirmation of everything. Yeah, go on then. OK, right, so it's suggesting that we should run get secret number. And I say, yes, you are allowed to do that. Go ahead and do it. And it comes back with 1, 2, 3, 4. So it's all working. Lovely. All right, so that is working with MCP servers. Last thing to bring up then now, how could we make the development experience a little better with some special tooling for working with prompts? Now, this is just an experiment. We've got no commitment to ship something like this right now, but I'm bringing this up now as a form of customer research. So I'm really interested in your perspectives on it, and if you want to learn more about how to do it or maybe try it out, then just come and chat to me afterwards, and I'd love to talk to you about it. Okay, so the scenario that we're trying to improve here is the intelligibility of what's going on. So we've got this trace right now. It's a bit hard to make sense of. What I actually want is a more sort of AI-centric view of the world. So what I'm going to do is add these prototype tools to my application by go to Manage NuGet Packages, go to my secret package repo, and then I'm going to install a couple of packages. Don't pay too much attention to how I'm doing this, because none of this is how it would really be if this was a real product. This is just, me making an experiment work. Then I'm going to come into here, and I'm going to say I want to make available prompt tools support, like that. Then I'll start the application back up. All right, and now I'm going to start up this other set of tools when I find my console window, .NET Prompt Inspector. All right, so again, don't pay too much attention to the fact that this is a web UI or that I launched it from the command line or anything like that. Nothing about that is a necessary part of the idea here. What really we're interested in is the experience for a developer, and is it actually helpful? So I could go back to my chat URI and now say hi, and I'll give it some tasks to carry out, like what does the watch do? So we know that that's hopefully going to do, oh, hold on. No, I'm not interested in that. Tell me about the watch. What does it do? It's not answering at all, is it? What is your problem? Let's, okay, this is actually a really good test scenario, because the whole point of this tooling is to help us diagnose what our problems are and to fix them. So let's see if we can use the tools. I genuinely didn't try to make that fail, but it did. So let's see if we can fix them using our tools. Right, so over here, you can see that it's been keeping a log of all the interactions we're having with our chat system. Okay, so I could go into one of those and I can see what has actually happened. So I can see a whole log of the conversation. I can see the prompt that's been used with the system prompt. We can see the user messages, the responses that come back. We can see that for some reason it decided to do a call to get the secret number. This is the response that came back from the MCP server, and here it answered the question about the secret number. But of course, I don't want to talk about the secret number now. So I realize as a developer, okay, there's something wrong with my prompt. The way that it's fixated on the secret number has kind of thrown it off track here. So let's see what would happen if I remove that from my prompt. So not only can I see what's been going on, I can try changing it as well. So I'll just remove that line there, and I'm going to restart my conversation from this point. I can restart it from anywhere. So I'll click that there, and we'll see how does it behave if the prompt had been different. So this time it does a call to search, passing in the phrase, what does the watch do? Now it gets a result back from the vector database, and it produces an actually useful response. So as a developer, we can see, all right, clearly I need to update my prompt there to make that work a little better. Okay, so that's fine, but can we take this a little bit further and make it more convenient for us as developers? Well, let's try and do that. So over here in our chat.razor file, you see we've got this big system prompt over here, and I'm going to get rid of that because we know that that's a problem. Right, so we've got our system prompt, and it's a big string literal. What if we don't want it to be a big string literal? Okay, I'll put that over onto my clipboard, and I want to put that in a separate file now. So I'm going to create a new file, new item, and I'm going to call it assistant.prompt. Now, what is a prompt file? Well, it's actually derived from the prompty file format, but that doesn't really matter for now. The thing that matters is it's a way of us defining AI prompts and interactions. So I'll paste all that stuff in and fix the indentation. All right, and I've just defined a system prompt. I could also define other user messages and other things, but I just want to do a system prompt for now. I also want to work around a little bug that I know happens, but you can ignore that. I'm sure that won't happen when you do this. Well, it will, but you know, when we'll fix it eventually, don't worry. Then I'll go back to chat.razor, and now I'm going to use that. So I don't have this system prompt variable anymore, but I've got some code generation. So since there's a file called assistant.prompt, it's code generated a C# type called assistant, which I can now format into the conversation. So I could say messages.addRange, and we'll format that in there. Okay. Now I know that looks like a little bit of a clumsy way of doing things, but you'll see the benefits of it in a minute. I also need to do that when the conversation gets reset. Okay, so if I rerun the application now, it will just behave exactly the same as before. It won't have any additional capability. Oh, in fact, I do need to restart it to show you this. So it will just behave the same as before, except it's just now getting the prompt from another location. So that actually happens at build time. It's not like reading the file from disk at runtime. And I'll ask it a question like, what year, I can't type, what year is it? Okay, what year does it think it is? Nope, sorry, I won't answer that question. Okay, that's again because of my prompt, so let's just fix that. I'm going to go into my prompt. You can answer about the year. Okay, let's try that again and see what it would have said. It would say the year is 2023, which is a controversial opinion, I would say. Now, why does it think that? Because, of course, it has got no access to the external world. Well, I mean, it's got access to various tools that are given it, but none of them will tell it its year. So it just goes and looks in its model weights. Well, the model weights tell it that based on when its training cutoff was, it was 2023, I assume. That's why it thinks that. So I'm going to need to put a bit more information into the prompt. So I'll say the year, let's say the date is current date, and that has to be a date time. All right. So now that I've done that, if I go back into my code over here, hopefully I'm now going to get a compile error because I'm using assistant.format and it now needs a current date. It didn't before, but it does now. So I'm going to pass in datetime.now. And the point here is that we've got a strongly typed way of consuming our prompts that guarantees we always pass the right dynamic data that they need. So let's try that one more time now. Come back over here and restart. What year is it? And it actually should know from its prompt. But actually, oh yeah, it does. Okay. I thought it was going to refuse to answer again since I didn't explicitly give it permission. But anyway, it's done that. The current year is 2025. Okay, so that's cool. Now, maybe I think that that's too laborious a way of answering the question. It could have just answered just by saying 2025 and not anything else. So I can come back into my prompt tools and I can see what we've got now. We can see that there's this current date parameter with this value. I could try out typing other values and see how it behaves. But I can also experiment with changing the prompt to make it behave in specific ways. So I could say something like, if answering about the year, reply with a single number and no other words. Obviously, this is a bit of a weird thing to do, but in realistic applications, you often do want to give it instructions about how exactly to answer certain questions. So that's the weird policy that I want to have in this case. So I'll try and see what it replies, and it replies exactly with a single word there, as well as a citation. I could tweak that as well to say, and no citation. So I can experiment with this iteratively, and oh, still giving me a citation. All right, I don't care about that. We could be more aggressive in our prompt. We're giving it contradictory information right now, like always include the citation. I'll just remove that. Oh, all right, whatever, I'm not bothered. But the key point is, after we've messed around enough and we get a prompt that we're happy with, we could copy and paste it back into our sources, but because it comes from a single file now, we can just click on a save button. So I'll just click save assistant.prompt, and then when I come back over here, you'll see that it's already been updated inside the source code there. So I could just hot reload or rebuild or whatever else it is that you want to do. Then I can come back and try that again. What's the year? And then hopefully we'll get back our single wired response. And it even didn't produce the citation this time, so that's nice. All right, so the benefit of this thing is that we can inspect the history of what's been going on, we can diagnose problems, we can change the prompt, we can change the parameters, we can see the tool call results, and we can even edit our prompts directly in this interface. So it's just an experiment we're doing, and definitely curious to know what people think of that, or if you think there's other things we should do instead, other ways that it could work. So there we go. We are down to the last minute, so I'm going to shut up and let you go and get some coffee. Yeah, we've covered a lot. Hope that was useful, and I really hope you enjoy the rest of this day. So thank you very much.